Perfect. Okay, so I have x plus 2 on the top. Then I have x plus 2 and x minus 2. Yeah? Okay, from there, what is going to cancel out? Okay, what does that create in the graph? A hole. Very good. Now, if it's an x plus 2 that cancels out, what is x going to equal where the hole is? Negative 2. So if you want to fill in the blank here, factors that cancel out create a hole in the graph. This is the notes, just the bottom part of them. Okay, now a vertical asymptote is a factor in the denominator that does not cancel out. So that's going to be a vertical asymptote. Now remember, just like we talked about in your notes yesterday, hopefully, if you watched it, okay, denominator means the bottom. So where is my leftover x for this guy? On the bottom. And if it's an x minus 2, where is the vertical asymptote at? Positive 2. Very good. Okay, look at the one right next to it, letter B. Okay, top is going to stay the same. What can I factor out of the bottom of letter B? This is a GCF. Okay, 3 and? Can I take out an x? Yep. So 3x is going to go to the front. What is left over from the 3x squared? Just an x, right? And then 6 divided by 3 leaves me with a plus 2. Okay, from there, what's going to cross out? X plus 2's create holes in the graph. So my hole in the graph will be at negative 2. Where will my vertical asymptote be, though, if my x is out in the front? Good. X in front means x equals 0 for my asymptote.
Why is it not?
Because it was a plus 2, and remember, you always change the sign. So if it's a plus 2 that crosses out, the hole will be at negative 2. If it was an x minus 2 that crossed out, the hole would have been left at positive 2. Okay, so that's what you should have learned yesterday. Do you remember it somewhat? Okay, now the new stuff we're going to add are these two. Okay, so roots you can pretty much already do, but we're not going to see them on the front. Okay, factors that don't cancel in the numerator, which is the top, those are going to be roots. Now, look at both of the examples that we just did. Did either one of them have an x left over on the top? No. So that's why for both of these, I'm going to put none. Okay, but when we flip over to the back side, you're going to see examples where factors are left over on the top. So I'm going to put none because no x's left over on top. Okay, that's where the roots come from. So if you don't have any x's left over on top, then you just don't have any roots. Okay. Alright, so here is how you find a horizontal asymptote. There are 3 easy little acronyms for you to know to remember them. So come up to the very top. Okay, your choices are Bobo, Botan, and Bedsy. Okay, so here's what they stand for. For you to find an asymptote of a graph, okay, you are going to compare the degree of the denominator to the degree of the numerator. Now, degree means power. So when I say I'm comparing the degree of the denominator and the numerator, okay, if I'm looking for Bobo, that means bigger on bottom, y equals 0. So it's bigger on bottom 0. Now, this is what I mean, though, by power. Okay, so if I'm looking at letter A, the first one, okay, the top is an x2, the bottom is an x3. Which one is bigger?
X2. X3.
X3. And where is x3? On top or on bottom? So it's bigger on bottom than it's 0. Okay, now look at the one right next to it. I noticed that on the second one, I don't even have an x on the top. That's the same as like having an x to the 0. And then on the bottom, I have a 6x. Well, that's like a 6x to the 1. So if I have x to the 0 versus x to the 1, which one's bigger? the x to the 1, which is on the bottom, so that means y equals 0. Okay, next one. If the degree of the numerator, that's the top, is greater than the denominator, you're going to use bottom. So instead of bigger on top, what do you guess bottom stands for? Bigger on... Okay, so bigger on bottom for Bobo, bigger on top for Betsy. And then the n stands for none. So if you are looking at a fraction where the top is bigger, you would say there is not an asymptote. So looking at letter C, what is the highest power of x on the top? x5 versus, look on the bottom, it's an x2. Which one's bigger? Bigger on top, so it's none.
That's all we're doing?
Okay, now look at letter E at the bottom. We're going to skip D, we'll come back to it. Look at letter E. This one is already factored for you, but in order for you to know if it's a Bobo or a bottom, you're going to have to times it out. So if I'm looking at letter E, what is 3 times 2x? 6x. Okay, then 3 times minus 1 is minus 3. On the bottom, what is 2x times 3x? 6x squared. And then 2x times plus 1 is a plus 2x. And then once I times it out, I can look at those powers and see which one is bigger. So I have a regular x on top. I have an x squared on bottom. Where is it bigger? Okay, so that's bigger on bottom than it's a Bobo. So bigger on bottom goes to 0. What if it was bigger on the top, would I have put? None. Okay, the last option is bed C. So bed C is both equal. Divide coefficients. Now, do y'all know what a coefficient is? Okay, a coefficient is just like the number that's in front of the x. So, for example, if I was doing letter F here, what is my highest power on the top?
3.
x3. Now, be careful. What is the highest power on the bottom?
5.
Okay, there's an x2 here, but that's not the biggest. The x3 is the biggest. And do you notice that it's a tie? I had an x3 on top. I have an x3 on bottom. Then divide the coefficients. Means you put the numbers on top and on bottom into a fraction. So it would be y equals 3 on top, 5 on bottom. Okay, but you have to pull the coefficients that go with the x's that matched. So like I can't use the 1 from the x squared. I have to look at the x3s, take the numbers from the front, make a fraction out of it. Okay, look at letter D right above it. Is that a Bobo, a bottom, bigger on top, bigger on bottom, or is it a bed C, both equal? It's a bed C. Even though they're out of order, what is the highest power on the top and the bottom of that fraction? It's x3 versus x3. That's a tie. So then I do y equals, both equal, divide coefficients. What's the number in front of my x3 on the top? 4. -4 over. What's the number in front of x3 on the bottom? 2. -4 divided by 2 is -2. Make sense? So it's either a Bobo, a bottom, or a Betsy. Those are your 3 choices. It'll be 0, none, or it'll be a fraction from the numbers in the front. Okay, so let's finish examples A and B at the bottom. Look at letter A. Which power is bigger, the x from the top or the x squared from the bottom? Okay, that makes it a Bobo. Bigger on bottom goes to 0. Okay, look at letter B. I have an x on top. I have a 3x squared on bottom. Who's bigger? X squared wins, so that one is also 0. Okay, when you're ready, flip over to the back. B is also a Bobo, yes ma'am. because x squared on the bottom is bigger than regular x on the top. Okay, turn to that next page, please. Next one we're going to look at is letter D. Okay, first thing I want you to do is think about what your Bobo, Botner, Betsy's were on this one. Can I find it when these bottom x's are split up? Okay, no, I need to times x. What do I get on the bottom? X squared. Now, there's going to be other terms, but I only care about the biggest one. So if it's x cubed on top versus x squared on bottom, who's going to win? Bigger on top or bigger on bottom? Bigger on top, that makes it a bottom. Bigger on top, none. So I'm going to put a none here. Make sense? Okay, then the other three you have to factor to do, and this is what we learned yesterday. So notice that the bottom of that is already done for you. They already broke it down, so it's an x plus 2 and an x minus 1. But the top of this, I'm going to have to factor to fix it. Now, you learned in your video yesterday there are 4 ways to factor: GCF, perfect squares, T-chart, or one of your cubes, which is like the special rules. So look at the top of that. Is there a GCF I can pull out?
Yeah.
What is it? 4x. Very good. So I'm going to divide by 4x to the front. What will be left over when I pull the 4x out? It was a 4x cubed. X squared. Very good. Okay, then I had a 4x and I divided by 4x. What's 4 divided by 4? Minus 1. Now I look at that and I'm like, it doesn't really cancel out. But if I can factor again, I have to do it. How can I break this guy down one more time? Square roots. Square root of x squared is x. Square root of 1 is... So I did 4 divided by 4. That goes away to the outside. Then x3 divided by x leaves an x2 here. Then for the second one, I did 4 divided by 4. That's where the 1 came from. Okay, so then I'm going to factor this one more time. So my 4x is still in the front. What is the square root we said of x squared minus 1? How do I split it up? What would it be when I break that down? Plus 1 and minus 1. Now, look at what's on the top. Look at what's on the bottom. Is there anything that is going to cancel and create a hole in the graph? Okay, the minus 1's cross out, then where will the hole be? X equals positive 1. Remember, you just reverse the sign. Okay, vertical asymptotes are left over on the bottom. What x was left over on the bottom? X plus 2. Then where will the vertical asymptote be at? Negative 2. Okay, and then the other new thing that we added were your roots. Where are those left over, we said, on the top? So where are my x's left over on the top? I see 2 of them. X plus 1, I'm going to have a root. And then 4x, I'm going to have a root. X plus 1, what is the reverse of that for me to list? Negative 1. And then what about when my x is out in the front like that guy? Nope, 0. So remember, whenever you have an x out front, x equals 0 for that guy. Make sense? Oh, I meant to put 0, sorry. So whenever you have an x out front, 0 is the answer that goes with that. Okay? Alright, next one that we're going to do is letter E. Go down to letter E. Okay, so I'm switching down to letter E. First thing I want to do is find my horizontal asymptote. Will that be a bobo, a bottom, or a bed C for letter E? Okay, it's a bed C. I have an x squared versus an x squared. That means it's a tie. So it's a bed C, both equal. Divide coefficients. What are my numbers in the front? 3 over 7. Very good. Now, if 3 could divide by 7, I'd do it. But since it can't, I'm just going to leave it. Okay, Okay, so from there, in order for me to find the wholes in the asymptotes, I have to factor. Now, on the top, 3x squared plus 2, are those square rootable? No. Do they have a GCF? Can I t-chart it? Is it a cube that I can use a formula for? No, then leave it alone. So 3x squared plus 2, okay, I cannot fix that. That's called prime. Cannot be factored. And if you get a piece of it that cannot be factored, you just leave it alone. Okay, now on the bottom, I can factor that. What can I take out of the bottom as a GCF? Can be a number or a letter. X. So I'm going to take my x out here to the front. What's left over from 7x squared? 7x. What's left over from 5x when I pull the x out? Just a 5.
How come we can put on an X and not the top?
Because on the top, the 2 did not have an x. If it did, I could have taken an x out as well from the top. Okay, now look from there. I want to see if anything can cancel. What can cancel? Is this x out in front like that one? No. So none, because nothing cancels. Okay, and that's okay. If you don't have a factor on top and on bottom that match, you can't cross anything out. That means that graph won't have a hole in it. So instead of having one hole and one asymptote, they are both going to be asymptotes. Now, for this x out in the front, where will the asymptote be? 0. And then for the x in the parentheses, remember, you change the sign, put that number on bottom. If you don't remember, you can set it equal to 0 and solve, and it'll give you the same thing. So if I take my 5 and I scooch it across, 7x equals negative 5, then where does the 7 end up? On the bottom. So x equals negative 5 over 7. But notice I ended up with 2 vertical asymptotes on that one because I had 2 x's left over on the bottom. Okay, now remember that your roots are left over on the top. My only x left over on the top I could not break down. So what do you think I'm going to put for root? You would put none. Okay, because x is left on top, can't break down. So remember, you have a lot of ways to break them down, but if none of them work, you're not going to have a root. Make sense? Okay, so you have a couple examples on here. We're going to switch and do 2 examples off the homework, just to make sure. I know yesterday with me being gone, I don't want anybody to be confused. So take a look at your homework. You're looking at homework 3. We're going to do number 4 off the front. Okay, so first thing on number 4, horizontal asymptote, you're using your Bobo, Bot, and Betsy rules. Which rule applies for number 4? Looking at that one, it's a Betsy. Because I have an x squared on the top, I have an x squared on the bottom, that makes it a Betsy. And remember, for Betsy, both equal, divide coefficients. But what is the coefficient on top in front of the x squared, even if I can't see it? It's like a 1x squared over a 2x squared, so it's 1 over 2. Everybody good with that? Okay, to find the other 3, we have to factor. How can we factor the top here? T-chart, very good. So for my t-chart, I need numbers that multiply to 8 and that add to 6. What could I pick? 2 and 4. Good. So I'd have x squared plus 2x plus 4x plus 8. And then I'm looking for a GCF between the first 2 and the second 2, just like we've now done forever. First 2, take the x out. What's left over? Yep. Second 2, what's left? What can I take out? 4. What's left over? Good. Which means that my factors on the top are x plus 2, because that's my little repeater, and then x plus 4 from the outside. So the top breaks down into x plus 2 and x plus 4. Everybody good to there? Okay, now look at the bottom. The top we did a T-chart on. How are we going to break down this bottom? Right here. Divide by 2x, which is a GCF. So they can both divide by 2, they can both divide by x. I put my 2x here in the front. What's left over? And x from the 2x squared. What about 8 divided by 2? Plus 4. Then I look for what can cross out. What can cross out? My x plus 4's. Which means where will the whole be in the graph? Switch up the sign though. If it's a plus 4 in the parentheses, it'll equal a negative 4. And then my vertical asymptote are my x's that are left over on the bottom. What x is left over on the bottom? 2x, and it's out front, so what's the answer that goes with that? 0. Okay, then my roots are the x's left over on the top. What was left over on the top? X plus 2, which means the root will be x equals negative 2. Does that make sense? Okay, so I'm going to label on this one. Okay, you're doing Bobo, Botan, Betsy. Okay, these are the ones that cancel. These are the ones that are bottom leftovers. And then these are the ones that are top leftovers. Okay, that way you have it all kind of like listed out on your paper what you're looking for. Yes, ma'am. Sure. Okay, so rewind back, look at number 2. Does number 2 count as a Bobo, a Botan, or a Betsy? Okay, it is a Betsy. Because my power on top is an x3, my power on bottom is an x3, that makes it a tie. What coefficients will I be dividing top over bottom? 3 over 1. Now, can 3 divide by 1? What is it? So you can just put y equals 3, but if you like 3 over 1 better, that's fine. Same thing. Okay, now from there I have to factor. What can I take out of the top? 3, and can I take out anything besides an x and a 3? X squared. Very good. So from the top, I'm going to take out a 3x squared. Out of my 3x cubed, I'll have 1x left over. And then 6 divided by 3 will leave me with a plus 2. So far, so good? Okay, on the bottom, I have x cubed. And then I'm looking to see what can cancel out. Okay, now this is a little bit tricky, but I want you to think about, can any of these x's cancel out? 2 of them can cancel out. So look, watch. Instead of writing it like this, I'm going to make it x squared times x. Now, is that the same as x to the 3? Yes. And then look what I'm going to do. I'm going to cancel out these 2 and these 2. So if x was by itself, where would I say there's going to be a hole in the graph? But it's kind of like out in front. It's not in a parentheses. What goes with that? 0. And then I have another x left over on the bottom. He's not a parentheses either. What does that make it? He's out front, so it's a 0. And then my roots come from whatever x is left over on the top. What x is left over on the top? Negative 2. Very good. Okay, last one we're going to do together. Flip over to the back. Okay, so remember that your only x's leave you with leftovers. So the 3 on the outside by itself does not make a difference. It doesn't create anything in the graph. Okay, you want to do 5 or 6? 5. 5, okay. So take a look at number 5. Bobo, Botan, or Betsy for number 5? It is a Bobo. Why is it a Bobo? Because it's bigger on the bottom. So what do I put y equal to? 0. Because it's an x squared on the top, it's an x3 on the bottom, x3 wins. Okay, from there, in order for me to factor the top, what am I going to do? T-chart. I need numbers that are going to multiply to 1. Well, then what are my only choices? 1 times 1. Does that also add to 2? What if I want a negative 2, though? Negative and negative. Good. So I'm going to have x squared minus 1x plus 1. First two guys, what can I take out? X. What's left over? Minus 1. Okay, second two guys, what can I take out? 1. Now, if the first one's negative, remember you have to pull out the negative as well. So negative 1 comes out. What's left over? X minus 1. Okay, then from there, I look at my factors. These guys match. So x minus 1 is my first factor. What is my second factor, though? X minus 1 again. Now, if you like it better, x minus 1 squared, that's fine. Same thing. Okay, now, you look at the bottom. What method am I going to need to break that down? Use your sum or difference of cubes. And notice your formulas, they're down here at the bottom. Okay, so what is the root of x cubed here? X. Do we remember the cubic root of 27? 3. And so then when I use my formula, my a is going to be an x, my b is going to be a 3. So a is going to be x, b is going to be 3. Now, let's pick which formula I want to use. Look at your formula carefully. I have a plus in the middle. So am I going to use the top formula or the bottom formula? The one with the plus. And I'm following this right here. So, ready? First I want to put in a plus b. A is an x, b is a 3, so it's x plus 3. Are we good with that? Okay, then from there I need an a squared. Well, that's x squared. Okay, then I have a minus ab. Well, if a is x, b is 3, that's a 3x. So minus 3x. And then b squared is going to be 3 squared, which is 9. Okay, look at your factors on top and on bottom. Can anything cross out? No. What do I put for holes then for the graph? None. Okay, because nothing canceled. Okay, vertical asymptotes are any x's left over on the bottom. This is an x plus 3. Where will the vertical asymptote be at? Negative 3. Now, if you remember using the cubes formula, this guy doesn't give anything. Okay, that you can ignore. Okay, the second little part of the formula never gives you an asymptote or a hole or anything like that. You could try to t-chart it, but it won't work. Okay, the last thing I have to find are my roots. Where are those left over on the top? So if I have an x minus 1, where will the root be? Positive 1. Okay, then I look at my second one. It's also an x minus 1. So its root is going to be the same. Make sense?